We're going to rewrite each one of these in summation notation. Either one of these is fine. I usually put my constant out in front, so that's probably how I'll end up writing it, but either way is fine. And then once we've written in summation notation, we'll determine if the series converges or diverges, and if it converges, we'll find the sum. And just as a reminder, we can only find the sum if it's a geometric series. So some of these other series tests that we're going to be doing later on, we won't be finding the sum that it converges to. We're just going to determine if it converges or diverges. Okay, so our first one is 1 plus 2/3 plus 4/9 plus 8/27. This 1 out in front, that's my first term. And so I know that C is equal to 1. And to find R, I can take any two terms that are adjacent and divide them. So I'll do 2/3 over 1, so that tells me that R is equal to 2/3. So in summation notation, this is equal to 1 times the sum from n equals 0 to infinity of 2/3 raised to the n. So this is a geometric series because we have a number raised to the n. So I know I have a geometric series. And the criteria I'm interested in is the absolute value of R. So R is equal to 2/3, which is less than 1. So that tells me that I have a convergent geometric series. Okay. And then I can find what this sums to. So our sum is going to be the first term, which is a 1, over 1 minus R. So 1 minus 2/3. The second one, 2 plus 2/3 plus 2/9 plus 2/27. So the 2 is my first term, and in order to maybe see this a little more clearly, I'm actually going to factor that 2 out. So I get 2, and then I have times 1 plus 1/3 plus 1/9 plus 1/27. Okay. So there's my C. And then my R, I think it's pretty easy to see that R is 1/3, but if not, if you're stuck on that, send me an email. So this will be equal to 2 times the sum from n equals 0 to infinity of 1/3 to the n. So I have a number raised to the n. That gives me a geometric series. The absolute value of R is 1/3, which is less than 1. So I know that this converges. And it's going to converge to my first term, which is a 2, over 1 minus R, so 1 minus 1/3. All right, so number 7, 1.5 plus 3 plus 6 plus 12. I'm going to have you go ahead and pause the video and give that a try yourself. So as Dory likes to say, just keep swimming and pausing the video and trying the problems. Okay, so hopefully you paused that video and gave this a try. Let's see if we got the same answer. So my first term is a 1.5, so that would be my C, and I'm going to go ahead and factor that out so I can kind of see more clearly what's going on. So if I pull a 1.5 out, I get 1 plus 2 plus 4 plus 8. So that 1.5 is my C, and then it looks like I'm multiplying by 2 each time. So that gives me R is equal to 2. So this will be the sum of 1.5 times 2 to the n. Okay, so I have a number raised to the n. It's geometric, that's a good sign. Geometric series, and the absolute value of R is equal to 2, which is greater than or equal to 1. So this is a divergent geometric series. And then number 8, so this is the first one we have with alternating signs. Again, I see that 125 is my first term, and I'm going to go ahead and factor that out just so I can more easily see what else is going on here. So if I pull the 125 out, I get 1 minus 1/5 plus 1 over 25 minus 1 over 125, and then it keeps going. So 125 is my C. My R, so again, I can use any two adjacent terms. So I'll use that negative 1/5 divided by 1. So my R is just a negative 1/5. I can rewrite this as 125 times the sum from n equals 0 to infinity of negative 1/5 to the n. So this is a geometric series because I have a number raised to the n. The absolute value of r, so my r is -1/5, but the absolute value of that is 1/5, which is less than 1, so this is a convergent geometric series. So again, this would be the write-up that you would want to provide. If you were just asked, is this series convergent or divergent, this is what you would want to write out. And we can find, since it converges, we can find what it sums to. So we know the first term is 125. And then that's over 1 minus r. And so r is a -1/5. So you want to write that down at -1/5. So really that denominator is 1 plus 1/5.